Okay, guys, so this is a review of transformations that we looked at on Monday. So we're going to graph these. On 1, 2, and 3, the parent function is y equals 2 to the x. Y equals 2 to the x looks like this. Here. Okay, so everything we do is based off this parent function, y equals 2 to the x. So your first one, the first one is y equals 2 raised to the x plus 3 power. So if you're in Desmos, it's 2, and then hit the A to the B button, and then you have to use parentheses, x plus 3. Okay. So the blue graph was our original. The green graph is the new one, the transformed graph. How did it transform? What happened in that transformation? From blue to green, what did you do? Let's say this is a point, this is 0, 1. And this is the point, come on, 3, negative 3, 1. So we went to the left 3 units. And that's what this means up here. When it's with the x, when you have a number with the exponent, it's opposite of what you would think. So plus means you're going left. If you subtract a number, you're going right. So let's graph that. Let's get some points. Okay, so we've got some nice points. Let's see. Let's start at negative 4. Negative 4, negative 3, negative 2. Yeah. So we can start at negative 4. We've got all those nice points. So let's put that on our graph. And I'm going to zoom in. Okay, so the points we had were negative 4, so find where x is negative 4, and then y is 0.5, so 0.5 is going to be halfway between 0 and 1. So halfway between would be right there. Okay, then we've got negative 3 and 1. And we've got negative 2 and 2. Negative 1 and 4, 0, and then 8 is going to be way up there somewhere. Okay. All right, so let's see how we can answer these. What is my domain? Any guesses? Can it be any x value? It can. It's got arrows going left and right. It can be any x value.
Yeah. Good. Yeah.
I see you using Desmos.
Yeah. That I was on Snapchat. But guess what?
Hey, we are recording. I'm just checking. Okay, what is our range? Where do your y values start? No, let's draw the asymptote. What is the equation for that line? Y equals 0. Okay. So your range is always going to start at that asymptote. It's going to start at 0. So your range, your y values start at 0 and they go up. They don't go down here at all. So 0 to infinity. The asymptote we said was y equals 0. And from left to right, the graph is increasing. Okay? Let's look at number 2. Number 2 says f of x equals 2 to the x and then a big plus 3. Okay, so let's graph that and see what it looks like. So 2 to the x, so 2 and then AB, put your x, and then hit plus 3. So how did that transform? How did it move? Going from blue to red. Did it go left or right? Did it go up or down? Look. Going from blue to red, we're going up how many units? Up 3 units. Okay, so let's see what points we have here. I started at -1. Come on. This doesn't like me. Let's see. There we go. I started at -1, 3.5, 0, 4, 1, 5, and 2, 7. Those are about the points you can get. Those are about all the points on this graph. So we had -1 and 3.5. So -1 and up to 3. 3.5 is going to be between 3 and 4. So that's here. 0, 4, 0, 4. And we've got 1, 5, 1, up 5, and then 2 and 7. That is your curve. I'm going to go ahead and draw the asymptote. What is the equation for that line that I just drew? What y value is it going through? 1, 2, 3. So this equation is y equals 3. If it's a horizontal line, remember it's y equals. And it's y equals whatever y value it goes through. Three. It's 3. Let's zoom in so you can see it better. This is 0, 1, 2. Wait, nope. You're confusing me. Sorry. Wrong graph. So this is 0, 1, 2. That y value is 3. Because it's the line that the graph does not go beyond. It's got to be right there where it touches on it. It's an imaginary line that the graph does not go beyond. Okay? So the domain for this would be all real numbers. So -infinity to infinity. The range starts at 3 and it goes to infinity because your asymptote is y equals 3 because that's the imaginary line that it doesn't go past. And then it's increasing from left to right. Think about the asymptote as a line that your graph kind of sits on. Where is it sitting? Where's its chair? It's right there. It's not down here anymore. It moved up because you moved the entire graph up. Okay. Number 3, f of x equals 2 to the x minus 1, and then plus 3 at the end. So let's see how that compares to the parent function. So we've got 2 to the x, so 2 and then hit your AB button. Actually, you need parentheses. because it's x minus 1. And then plus 3 at the end. So, minus 1 moved the graph to the right 1, and then the plus 3 at the end moved it up 3. So some points we can get. I don't understand why it goes all the way over there. Okay. I would start at 0 and use those points. 0, 3.5, 1, 4, 2, 5, 3, 7. So let's zoom in. Nope, wrong button. Okay, our points were 0, and then up to 3.5 is going to be between 3 and 4. So 0, 3.5, 1, and 4. Then we had 2 and 5, and then 3 and 7. So again, that horizontal asymptote is this line, and it's y3, because the graph does not go beyond that boundary. Okay, so the domain, again, if it goes left and right, if it's got arrows at the left and at the right, your domain is going to be all real numbers. So we've got negative infinity to positive infinity. Range starts at 3, goes to infinity. Your asymptote, y equals 3, and it's increasing. Okay, so if you flip over to the back, this was kind of like what you had for homework the other night. Given the function f of x equals 1/4 to the x, that's your parent function. That's what you're basing everything off of. What would the equations look like if you applied these transformations? Okay, so a horizontal shift right 3 and a vertical shift down 2. So we've got f of x equals, we've got the 1/4 to the x, that's your parent. And then right 3, we're going to put minus 3 with the exponent. And what are we going to do for down 2? Minus 2. For a reflection, you're going to put you're going to make it negative. So f of x equals negative 1/4 to the x power. Vertical shift up 2. Okay, so f of x equals 1/4 to the x power, but it says horizontal shift left 4, so plus 4 with the exponent, up 2, we're going to put a big plus 2 at the end. And whatever that number is, the number at the very end, if you have a whole number at the very end, that is where your range starts. That is your asymptote. So the equation for the asymptote for number 9 would be y equals 2. Your range would be 2 to infinity. Okay. Number 10, a stretch of 5 and a horizontal shift right. Anytime you're stretching or shrinking, that is what goes in front of your B. That's your A value. So this is going to be f of x equals 5 times our parent function, which is 1/4 to the x power. And then right 2 is going to be -2. Then a shrink or compressed by 1/4. Remember, a stretch or a shrink, that's going to be the number in front of your B. So this is going to be f of x equals 1/4 times 1/4 to the x power. Okay, and then now we just have to look at these equations and decide how are they transformed? What did you add to them? And I'm going to highlight what we need to discuss. Okay. All right, look at number 12. Y equals 2 to the x minus 4. What does that minus 4 with the x do to the graph? What does it do? Moves it? How? Right? How many units? 4 units. Thank you. Good job. Number 13. What does the minus 3 with the exponent do?
Moving down.
Nope. Well, the 3. What does this do? Yeah, how many? Right, 3 units. What does the minus 7 do?
Down.
How many?
7.
There you go. It's down 7 units. Number 14. Got 3 different transformations.
Oh, and plus 2 was you left?
But what does the negative do? What does that do?
Yeah.
No, it starts with an R.
Predominating.
Reflect.
Left.
There. So it reflects over the x-axis. What does the plus 2 do? Right here.
Was you left?
Left 2 units. Okay, and then what does the plus 5 do?
Up.
Up 5. Okay, we're almost done. Number 15. What does the 2 in front do?
Multiply.
Yeah, but how does it transform the graph?
Right.
Is it a stretch or a shrink?
Right.
Right. If this is a vertical stretch by a factor of 2.
So this one would be B and the opposite of stretch.
Which is
I forgot what that's called.
shrink.
Shrink. Oh, B.
So number 16 would be a vertical shrink by a factor
You say 0.15?
of 1/2. Or you can say 0.5.